Some of you are going to be really happy with what we're doing today. Some of you may be less happy. But today, a whole lot of numbers. So, still writing, of course, because it's stats. But what we're going to be doing is we're still going to be looking at quantitative data. So we're still going to look at numeric data. But instead of describing it with a graph, we're going to describe it with numbers. So a lot of times what happens is you collect your data, you put it in a graph, and then if it's numeric especially, you have some numbers that summarize that data. Okay, so first thing that we need to talk about is we need to talk about these two symbols right here. So both are symbols for mean. And mean is just the stats word for average. Here is the difference though. X bar is the sample mean. So if I were to take the average for a sample, whereas mu is the population mean. So you're going to use the symbol based on do you have the sample or the population. 99% of the time, you have a sample, not the population. Okay, so formula for mean. You are going to add up all your observations and divide by how many there are. So that means the first observation, the second one, all the way to the nth one, and we divide by n. The other way to write that is sum up the x's and divide by n. Now, we've talked about when you have quantitative or numeric data and you're describing it, you do CSSU. So that C, that center part, is part of what we're talking about today. There are actually 3 different measures of center. First measure of center is what we just talked about, and that's mean. Any guesses as to either of the other two? Going back to like elementary school, what did you also do with mean? Median and mode. I will tell you, statisticians hate mode. Pretty much useless. So you're not going to use that at all. You'll use mean and median.
What is mode again and why is it useless?
Mode is just the most common occurrence.
Oh, yeah, that is kind of useless.
Okay, so here we go. This is a sample of 20 that we're going to be looking at all throughout notes today. And it's 20 different people, how long it takes them to commute to work. So the first person, it took 10 minutes, 30 minutes, so on and so forth. First thing that we're going to do, bless you, is we're going to calculate the mean. If I asked you to do that, you have to show the formula. So you're going to say, I'm calculating the sample mean. I'm adding up my x's and dividing by n. Don't show every x. That's a waste of your time. What I do is I show the first one, 10, plus, ... all the way to the last one. And then I'm dividing by all 20. Is it fair to say that you all can probably calculate average just fine?
Yeah.
So are you okay if I just tell you what the average is?
Yes, save us kind of typing in all these numbers.
Okay. It's 31.25. You have to show a formula, show a substitution before you show your answer. That's considered showing work.
I'm assuming that's in minutes.
This is in minutes. We also need to be able to interpret this. So that's what we're going to do next. This is the average for this sample. So it needs to be described in terms of the people in this sample, not a single person. So for the New Yorkers, in this sample, the average commute time is 31.25 minutes. Do not round your answer. So don't say that it's 31. Okay, we also need to be able to calculate median. You've done this before. Line up all the 20 observations, cross out from both ends. Now, I just want to know, without even doing that, where would the median be located? Kiara?
Like the average of number 10 and 11.
Very good. So if we take 20 observations and we split up 10 and 10, we see there's no number in the middle. So our median then would be the average of the 10th and the 11th observations. We're not going to do that, just because it's not the best use of our time. Okay, and if you were to interpret the median, it is just the middle observation. Okay. A new term for us, but that should probably be intuitive, is a resistant measure. A resistant measure of anything is unaffected by outliers. Do you think mean is resistant? No. Definitely not. So in the data set above, I don't know if you guys looked through the numbers, but there's this one observation of 85. That's really high. That's definitely one of the things that's pulling the mean higher. So if we took out this 85, the average would definitely be lower. Okay, next thing. We need to be able to estimate from a histogram or a dot plot. Two different ways that you can do that. First way is mean is the balancing point. And secondly, all of the deviations will sum to 0. So here's what I mean by that. Make yourself a number line from 1 to 8. So just do that real quick. Make yourself a number line from 1 to 8. Doesn't have to be super accurate. And I'm going to tell you to put down 3 numbers. Put down 1, 2, 3. So 1 dot at 1, 1 dot at 2, 1 dot at 3. 1 dot at 6, 1 dot at 8. Okay, so you have to think of each of those dots like a 1 pound weight. So think of them like a 1 pound weight, and they're all on a platter of some kind. The mean is wherever you would have to put your finger, assuming you could hold up 5 pounds, to keep this platter balanced. Where that would end up being is 4. That's where the mean is. Now, to prove that that's the mean, we're going to look at these deviations. So from 4 to 6 is 2 above. From 4 to 8 is 4 above. Now, if we go the other direction, from 4 to 3 is 1 below, and then we have 2 below, and then we have 3 below. So we will see if we add all of those up, we get a sum of 0. Okay, moving on to median. Do you think that median is resistant?
Yes.
Yes. The median is not going to be affected by outliers because it's just the number in the middle. Okay. Last thing about mean and median, and then we're moving on. how shape plays into mean and median. So if the distribution is symmetric, the mean and the median are going to be about the same. The skew affects the mean. So a skew is unusual observations, outliers, that's going to affect the mean. So for example, if we have a distribution like this, the median is somewhere about here, the mean is going to be pulled towards that tail. So the tail or the skew is always going to pull the mean.
Which one would you be better off to use to describe your graph?
That is such a great question. Really, it depends on what you're trying to do. If you are just a statistician and you want to be accurate, the median. If you are talking about salary, like we offer a great salary, you're going to use the mean. Did you guys hear that question? Because that's something that you're going to be asked, is should you use the mean or the median? Generally, if the distribution is skewed, you're going to use the median because it's more accurate. But do know that the mean is sometimes used in a case like this to prove a point of some kind. Okay, we're going to talk about one more thing, and then we'll take a break. Okay, this is a throwback. Do we remember how to calculate range?
Top, largest one.
Canaan?
Top number subtracted by the smallest number.
Okay, range, thank you. The maximum subtract the minimum. Biggest number subtract smallest number. Do we think range is resistant? No.
Again, outliers change.
Yep. And I forgot to say we're moving into spread now. So mean and median are measures of center. We're now going to look at numeric measures of spread. So variability. Okay, so we're going to keep going down this track with spread. We're going to talk more about spread, and then we're going to look at the calculator, and then we're going to take a look at a new graph. Okay, so next thing to talk about is quartiles. These, you might have heard them before. It's not really a measure of center or spread, but it is something that will be used. So Q1 is called the lower quartile, and it is the 25th percentile. In other words, it's the median of the first half of the data set. Q3
I remember this. Oh.
is the upper quartile. It is the 75th percentile. So it is the median of the second half of the data set. So we have this New York commuter data. What we would do is we would order it. So there's a 5, there's 2 10s, so on and so forth. I'm not actually going to do that. Not a good use of our time. But it is important to me that we know where Q1 and Q3 are. So here's how I would do that. I have 20 observations that get split 10 and 10. So we already talked about between these 10 is the median, right? The average of the 10th and the 11th. Q1 is the median of these 10. Q3 is the median of these 10. So if I think of the first 10, these would be split 5 and 5. There's nothing in the middle. So Q1 would be the 5th and the 6th observation, and I would divide by 2. So same thing over here, 5 and 5. So my Q3, in terms of where are these, well, I have these 10 observations and then another 5. So it would be the 15th and 16th observations divided by 2. Now, your calculator pretty much is going to do this for you. So when we get to the next page, I'm going to tell you how to find those using the calculator. Okay, the reason that you find Q1 and Q3 is to find the IQR, or the interquartile range. IQR is Q3 subtract Q1. So I will tell you for our data set, Q1 is 15 and Q3 is 42.5. So then our IQR is that 42.5 subtract 15. So IQR is 27.5. The practical use of IQR is to find outliers. So is IQR resistant? Mostly. The only time it wouldn't be is if you had a really small data set. So if your data set was only 3 observations and one of them was an outlier, that's going to affect the IQR. Okay. Outlier is an unusual observation. Unusual. So unusually high or unusually low? Okay, here is the deal with identifying them. If you picture your data set, 50% of the data is going to be between Q1 and Q3. So outliers are potentially bigger than Q3 and lower than Q1. Now, it's not anything lower than Q1, right? 25% of the data is below Q1. So we can't use Q1 as a cutoff. Likewise, 25% of the data is above Q3. So we can't use Q3 as a cutoff. What we can do, though, is if we take Q3 and we add 1.5 times the IQR, that is the cutoff for an outlier. On the lower end, we take Q1 and we subtract 1.5 times the IQR. Anything outside of those two numbers is an outlier. So if we're going to check our data set for outliers right now, the lower end, I'm going to do Q1 minus 1.5 times the IQR. So that'll be 15 subtract 1.5 times 27.5. So anything smaller than negative 26.25 is an outlier. Now, in our data set, there are no negative numbers. So there are no outliers on the left side. So no low outliers. In terms of high outliers, we take Q3 and we're going to add 1.5 times the IQR. So we're going to take 42.5 and we're going to add 1.5 times the 27.5. So anything higher than 83.75 is an outlier.
We do have an 85 in the data set.
So we do have one outlier, and it's at 85. We're going to talk about one more thing, and then we're going to go to the calculator. Okay, all of this information that I've talked about so far is generally called the 5-number summary. So the 5-number summary is the minimum, Q1, the median, Q3, and the maximum. Now, you could certainly find all of these by hand. We're not going to because that's a waste of your time. So now is when I'm going to show you how to do this on the calculator. Does everyone have an 83 or 84 with them currently? I want to make sure you know how to do this, though. Okay, so in order for the calculator to do its thing and calculate the 5-number summary, it has to know what the data is. And so it's going to need this entire data set. The way you're going to do that is on your calculator, you should have a stat button. So hit stat. And then the menu should say edit. So hit stat. And then when it says edit, hit enter. And you should be taken to a whole bunch of lists. Does everybody have an L1, a list 1? Okay, so what I want you to do right now is put in all of these numbers in list 1. So you'll hit 10, enter, 30, enter, 5, enter. Okay, so now what I want you to do is quit out. Just hit second quit. Okay, so now we want to do the actual calculation with those numbers. So you're going to hit stat again. This time we're not editing though. You're going to go to the right to calc. That's calculate. Okay, we are calculating number 1 var stats, and hit enter. Now your calculators are going to differ a little bit here. So we should be 1 var stats, and then we should hit enter. We need to tell the calculator where our data is. Some of your calculators will say list, frequency, calculate. Some of them will just say 1 var stats. But either way, the calculator needs to know your numbers are in list 1. It probably says list L1. Does it?
Yep.
Okay, is there anybody on the calculator that just sees 1 var stats? Okay, all you need to do is put in list 1. So the way you do that is you can hit center, not center, second, and the number 1, and L1 should pop up. Okay, and now hit enter. Or go down to calculate and then hit enter. Frequency list, you can leave blank. Error, okay. We should, so once you have your L1, go down, hit calculate.
Scroll down a number.
Oh, really? Okay, first thing that you should see is x bar equals 31.25.
Yes.
The mean that we calculated, I calculated and told you. Okay, there's some other numbers below that you should also see. The only one that we really care about is x bar, and then we care about s. We'll talk about that later. But in your homework, when you're calculating mean, don't do it by hand. Use the calculator. So you still need to show the work that I showed, adding the numbers up, but then you're going to use the calculator. Okay, scroll down. So hit the down arrow. And then you should eventually get to the 5-number summary. You should see all 5 of these numbers. Do you? So when I did this before, I found a minimum of 5, Q1 of 15, the median is 22.5, Q3 is that 42.5, and the maximum is 85. Okay, so finding the 5-number summary, you're going to use your calculator. I don't want you to do it by hand. Finding the mean, I don't want you to do it by hand. That's a waste of your time.
Lisa, then what work do you want us to show for the?
The mean is like the work we did initially. You're going to show a formula, show like the first and the last numbers that you're adding, and then just do the calculator. Good? Okay, we'll use the calculator in a little bit, but you can now put it to the side. 5-number summary, what it is used for is a box plot. You've probably seen these before. They're called box plots or box and whisker plots.
I remember these.
So that's what we're going to talk about next. Mean. Okay, here's our data. One more time. We're going to draw a box plot for this data. The first thing that we need is we need to draw our x-axis. Smallest number is 5, biggest number is 85, so draw yourself a number line. For easiness sake, I'm going to go 0 to 90 and just go by tens, because that is easier in my brain. And of course, this represents something, so you're going to write number of minutes. To construct this box plot, you need that 5-number summary. So maybe you can just copy and paste from your previous page. Okay, here's how the box and whisker plot works. Q1 to Q3 is the box. So the box is going to start at 15, which is Q1, and it's going to go to 42.5, which is Q3. So this will be your box. And then you're going to put a line at the median. You then have a whisker on the left, a whisker on the right. The whisker extends to the last observation that is not an outlier. So we already showed on the previous page that this 85 is an outlier. The way to show that is you put a dot there. So then our whiskers are going to go to the last number that is not an outlier. So on the low side, that's 5, because 5 is not an outlier. The whisker goes till 5. On the upper side, the whisker is going to go to the number before 85. So 85 is an outlier. If we look through all of our numbers, we see the next one is 65. That's not an outlier. So our whisker then is going to go until 65. And of course, you would put a title. I'm not going to because I'm lazy. Bless you. Okay. You always have to check for outliers. Even if there are no outliers, I want to see that you checked for them. We did that on the previous page. And then common error is, remember that IQR is a value, not a region. So what I mean by that is a lot of times people will say the IQR is 15 to 42.5. That's not IQR. IQR is a single number. So we could say the middle 50% is 15 to 42.5. But IQR is a single value. Okay. When describing a box plot, what you should be thinking is, this is numeric data. I've already done that. I know with numeric data, I'm going to do CSSU. There is one big exception here. And that is you cannot tell shape from a box plot. So you'll do center and spread and unusual, but you will not do shape. And you should be asking yourself, why can I not do shape? Well, box plot is based on 5 numbers only. Do you see that I can put whatever numbers I want in here as long as these don't change, which would change the shape? So box plot tells you nothing about shape, but you can talk about center, spread, and unusuals. Yes?
So when we're doing box plots, never worry about shape?
Yep. My strong preference would be you don't even mention it. It doesn't even exist.
Gotcha.
Okay, we're going to talk about parallel box plots, and then we'll take one more break before finishing notes. Parallel box plots, exactly what they sound like. More than one of them. So you could have like a box plot here that maybe is your New York data, and then maybe you have another box plot here that is somewhere else, LA. How do you compare them? You're still going to do CSSU, except shape still doesn't exist. Now, the one thing you can talk a little bit more about is we can discuss spread a bit more. Because we can look at different regions. We can look at the lower 25, the lower 25%, the upper 25%, the middle 50%. So there are different regions we can compare. When talking about spread, you don't need to talk about all of them, but you can just talk about them a little bit more. Okay, last thing that we need to talk about is what is called standard deviation. So standard deviation is the typical deviation from the mean. So if we were to calculate the average in this class, like the average amount of time it took you to get to school today, and then we were to find how far everyone was from that and averaged up those differences, that's the standard deviation. So this is a measure of spread. I'm not going to go through all of this. Here's what I need you to know. First, I need you to know the symbols. So the symbols for standard deviation are S and sigma. S is standard deviation for a sample. Sigma is standard deviation for the population. When you take standard deviation and you square it, you get what's called variance.
How do you write
Variance is just the square of the symbols.
Is
S squared and sigma
that
squared.
how you write sigma?
Yep, that is a lowercase sigma.
I-
Okay, practically, what are you going to be using? That. For the vast majority, you're going to look at standard deviation. The only purpose of variance is to find standard deviation. Okay. So, how do we calculate standard deviation? What you're going to do, you're going to take every x value and you're going to subtract the mean. So that's the deviation part. Now, if you remember from earlier in the notes, if we add up those deviations, we're going to get 0. Some will be positive, some will be negative. We don't want to get 0, so we're going to square that. before we add them all up. Then to get an average, we're going to divide actually by n minus 1, not by n. This is variance. So to get standard deviation, I'm going to have to take the square root. Okay, we need to actually use this formula to see how it works. So let's go to the next page. Okay, so reminding us of the formula. It's the sum of x minus x bar squared over n minus 1, and we're taking the square root of that. So we have a random sample of 5 students, and these are the numbers. I don't care about the context. What I care about is let's find the standard deviation. So what we're going to need is this is an x bar. So we're going to need x bar. That's just the average. You okay if I tell you the average?
Yeah.
Okay, so the average is 41. What we need next is we need all of the deviations. So that is x minus x bar. So if I do that with my numbers, I take 0, subtract 41. I'm going to get negative 41. 25, subtract 41, I get negative 16. 30, subtract 41, I get negative 11. 60, subtract 41, I get 19. And then 90, subtract 41, and I get 49. So that is just the part in parentheses. Bless you. And then if you notice, you can do a little bit of mental math, those are going to add to 0. So that's why we have to end up squaring them. So what we're going to do next is we're going to take those numbers, square them, and add them up. So I'll have negative 41 squared, add negative 16 squared, add negative 11 squared, so on and so forth. And that ends up being 4820. Lastly, our standard deviation comes when we take the square root of that 4820 and we divide by 4. So yes, there's 5 observations, but we do 1 less than that. That number is about 34.71. Okay. If we were to interpret this, it's the typical deviation from the mean for all the observations. So we would say something like, typically, the number of minutes spent on homework deviates by 34.71 minutes from the average or the mean time. For these students. It does not mean that every student was 34 minutes above the mean or 34 minutes below the mean. Doesn't even mean that most of them are. Okay, we're going to write down a few more things and then we will be done. two important things I need us to know about standard deviation. Standard deviation is always positive. Do you think standard deviation is affected by outliers? Yeah. Do you think if we removed that student that spent 90 minutes on homework, that would change the standard deviation?
Yes.
For sure, it would decrease it by a lot. So we say that standard deviation is not resistant. Okay, three last things to talk about. In terms of spread. In terms of spread, there are three different spreads we've learned. We talk about range, IQR, and now standard deviation. All of those are measures of spread. We need to talk about what do they have in common. What are their differences? In terms of similarities, they're all measures of spread. That's the big thing. Two big differences. First big difference is the resistance to outliers. And the second one is the amount of data used. Standard deviation is the only measure that uses all of the data. Both IQR and range only use two of them. Okay, center. So far, well, we've talked about mean and median. Spread, we've talked about range, IQR, and standard deviation. And so if you have a data set, you could calculate all of these. But often we want to know one measure of center, one measure of spread. How do you know which one to choose? If your data is symmetric, people tend to like the mean and the standard deviation. Those are easy to interpret. They're both averages. They take all of the data set into account. But they're affected by outliers. So if there is a skew or there are outliers of some type, the mean and standard deviation are no longer good reflections of the data. So instead, we would often use median and IQR. Two last things I want to say. When we did the standard deviation, that was a lengthy computation. Yes? You agree? Okay, on your calculator, you don't have to go through this with me. It still is the 1var stats. And you'll notice your calculator gives you sigma of x and s of x. You're choosing the s, not the sigma. So you would still show a formula, a substitution, and then use your calculator. So use your calculator. And then lastly, you do need to be able to read computer output. So that's what we have down here. What you need to be able to identify from here, just circle these with me. You should be able to find the sample size, the mean, the standard deviation, and the 5-number summary. We will not use SE of the mean, and we will not use N star. So you could be given this output and asked to make a dot plot. Not a dot plot, a box plot. You would know how to do that.